make the material, we will manufacture specimen. Okay, so this is your test specimen. By the way, I will post all the notes online also. So if you prefer to sit down and listen, fine. If you want to copy, you can do so. Okay. So these are the test specimens. So what happened for this case, okay, is they carried out uniaxial tensile test. Okay, so this is P1, P and P prime. So this is what we call a tensile test. They can also carry out compression. So with the same material you see here, okay, they can also carry out compression tests. So they can also do things like this. Compression. Okay, so this is where we call this as compression test. Or another thing that they could do, okay, another test that they could carry out. Okay, another test that they could carry out is they will do this now. Okay, so they will induce a torque or a rotation. Okay, so this is known as shearing test. So as you can see over here, if it's a tensile test, your stress will be always equal to positive. Compression, the stress will be negative. Now shearing stress or shear test, you get tau. Okay, tau value now. Now that is why if we were to go back to our table, we have the table. Let me, probably I closed the book already. Let me get the book again. So that is why if we look at the book, okay, or any material handbook, okay, we look at any material handbook, you can see, right? You can see the values, right? I'm going to copy this page. Yeah, I'm going to copy this page. So that is why you can see, okay, all these tests over here, right? All the tests, all the mechanical tests over here, as you can see, they are carried out by unidirectional test. Okay. So what does it mean by unidirectional? What you see over here, right? All this value over here, right, is due to what? Is carried out based on what? Tension. Okay. So carry out based on tension means they carry out the test over here. Just one direction. Okay, and that's the ultimate strength. And you will see you have nothing compression and shear. Now what we will see is you have tensile over here, and this tensile is only tested up to U. Okay, up to the U strength. So again, what you see, tensile means the test carried out is in that configuration. Sometimes you can see that we are given what? Shear. Okay, and shear, what they do is they do a torsional test. Okay. Now, what is interesting down here is you realize that most of the time, in fact, 95% of the time, okay, you'll see that the test is carried out in tension, usually, always the case. Okay, you can sometimes find in compression if it's a very brittle material, but usually you see tensile. So you can see over here. Let's compare. I want you to view this. Let's compare tension and shear in up to ultimate, and tension and shear. So what you see most of the time, we carry out tensile tests. Okay, we very seldom do shear. Okay, part of it is the setup is more difficult and it's also more expensive. Okay, now before I go any further, just to quickly refresh with you guys what we are measuring in terms of tensile, or what we mean by yield strength and ultimate strength. So we go through a stress strain curve. So I'm now sketching a standard mechanical test. So we will have one axis over here, and then we have another axis. Okay, so this is our strain, and this is our stress. Okay, so this is a standard behavior of our material. Okay, so what you will see over here, this point over here, is what we always address it at yield strength. And what we will see at the peak over here is what we normally call it our ultimate strength. It's common. Most of the time we are so familiar, we always call it ultimate tensile strength. Now what you see, we just address it in calling ultimate strength. Why? Because it can be carried out in tension, it can be carried out in compression, it can be also carried out in shear. So we just address it as ultimate strength. Likewise, the yield, we usually do them in tension or shear and in compression. Okay, so what we have over here is, I'm going to break this into two regions now. Okay, so you know that the region on the right hand side is the plastic region, and the one on the left hand side is known as the elastic region. So in this course, we are going to focus, okay, in this course, especially in this course, we are going to focus material behavior in just the elastic region. We are not going into the plastic region. Okay, now, any questions so far? Are you all okay? If you have, you can just stop me and I will answer your question. Okay, so don't hold back. I'm also looking at the chat. Anything that you have doubt, just stop me. Okay, I don't hear anything so far. So what is interesting now is, if we were to go back on the question, okay, go back to the question. We know that the material has a yield strength of 200 megapascal, and given to us is conducted in tension. Okay, tensile test. Okay, because the value over here is positive. Okay, the value over here is positive. So from here, now our dilemma is what? Okay, if we look at our diagram over here, okay, I'm going to copy. I'm going to go next page. I'm going to paste, right? And then I'm going to look at this diagram. I'm going to copy this diagram over here. Okay. So what we see on the left-hand side is the structure. On this diagram over here, the structure, or I won't call it the material, is under normal and shearing stresses. Okay, so the normal stress over here, I'll call it stress X, is equal to moment in Z over IZZ multiplied by Y. Okay, that is the normal stress. And then, so sigma X, I will define this as the normal stress in the x direction. Okay, mz is the moment about the z-axis. Okay, izz is our second moment of area, and our y is the furthest, or is the distance from the centroid. Okay, so the material is under normal stress, which we apply this formula, and the material is also going under shear stress. Okay, so shear stress, so the shear is equal to Vy over Izz Qz divided by T. Okay, so what do we mean by that? So tau is the shearing stress. Qz is the first moment of area. We already know what is Izz is. T is the thickness. Okay. So we realize that the material is loaded in two directions, right? You have a normal stress, you have a shear stress. Now, if you look at the tensile test, okay, if you look at the tensile test, so the tensile test, right, is used to determine the yield strength. Okay, so how they test this material? Okay, so I write stress yield is equal to P divided by area. So the area, so this over here is the area. So the interesting thing is, on the tensile test, you only see what? For this case, we call it what? Axial loading. When we load a structure based on this configuration, we have bending moment, okay, which is on left-hand side. So this one is what we call stress induced by bending moment. And then we have stress induced by shearing stress. Okay. So how is it possible? Okay, how is it possible, right? To determine, okay, how is it possible to use equation 1 and equation 2, okay, equations 1 and equation 2 to determine or to select or to ensure that the maximum stress is less than the stress yield. So the maximum stress over here is determined based on loading condition. And the stress yield over here is based on what? Experimental data. Okay, one is from experimental data, the other one is from analysis. Both loading are not the same. Okay, when I was a young engineer, I just ignore the shear. Okay, and I just compared the equation 1 with equation number 3. and that's wrong. Okay, that's wrong. You can't do that. You have to know, or you have